Hello, everybody. Good evening to lots of you. I think it's 10 o'clock in the evening for me in the UK. To get us kicked off, it will be lovely to know where everyone is in the world. As I said, I'm in the UK. I'm in a town called Tunbridge Wells, that's southeast of London. So if you'd like to share, put your location in the chat and we can see how international we are today. Miami, hello, Mindel. Belgium, not too far away. I've been to Belgium. Austin, Texas, Toronto, Virginia, Italy. I've got a friend living in Rome who I should visit. Yeah, Venezuela, Missouri. Oh, we've got a really good selection today. Okay, so for anyone who doesn't know me already, my name is Claire and I'm one of the TAs at Launch School. I'm also a student and I'm in the front end of the core curriculum. This is the first in a series of introductory workshops in Python. And these workshops are designed to complement Launch School's programming and back-end prep Python course. So as introductory sessions, I'll give you a flavour of Launch School and what to expect, but these are not a substitute for working through the course materials. An hour on data types and variables is not sufficient for Python. I can see a couple more people. We've got San Francisco and Amarillo. There was a song in the UK by a comedian. Anyway, right, so let's have a look at what these are all of the Python workshops. So today we're doing data types and variables, and then each Friday at the same time I'll be moving on to each of these topics. So we'll do functions and variable scope next time, then we'll move on to flow control and loops, list dictionaries and sets, which we'll cover a little bit today. Variables as pointers and mutability. Again, we're just going to cover variables a little bit, but in the fifth one, we're going to do that in much more detail. And then the last one is small problems in debugging, and that's going to be an interactive one where we're going to solve the problem together. So I'm looking forward to that one. So what are we covering today? So we're going to have a look at what Python is, then look at data types. Then we're going to look at primitive data types and then non-primitive data types. And as I said, at the end, we're going to have a quick look at variables. If you have any questions as we go along, please put them in the Q&A rather than the chat. If you put them in the chat, I might miss them, although I'll try not to. Whereas if you put them in the Q&A, I can keep track of which ones I've answered and which ones I haven't. The interface for sorry, the interface in Zoom is much easier if you put the questions in the Q&A. And I don't want to leave anyone behind, so feel free to ask questions. This is an introductory workshop, so there really aren't any questions that you cannot ask, because other people will go, oh, how do they not know that? Because this is going to have quite a range of ability, and you know, the idea is that everyone can follow along and understand. Now, at the end, there'll be time for further questions, and I'll also post a link to the feedback form. Now, I'm going to post that now, just in case anyone needs to hop off early. You can grab the feedback form and fill it in. Now, this is the first time we're running these Python workshops, so your feedback will be really important for making sure that these evolve and are helpful for students. So let me know what works. Let me know what doesn't work as well, so I can do less of that for the next people that go through this. So please fill in the feedback form. Everything in this workshop is covered in the Launch School Python book, so don't worry about taking notes. You can just sit back and enjoy the experience. If you want to code along, then please go ahead. Don't worry if it doesn't work for you. I'll be using multiple choice quizzes throughout to keep things interactive. The quizzes are just for fun. They're anonymous. I can't see who is clicking what. I can see how many people. They're all multiple choice. Select each option, but I can't see who, and we're not recording it, so don't worry. And for the Python course, we recommend using a Mac and Visual Studio Code to edit your code. So that's what I'll be using today. If you've got a Windows machine or you need to use AWS, so Amazon services, that's fine too. And Launch School's Python book contains instructions to get Python up and running in these environments as well. If you have any problems, either setting things up or working through the course, in Slack, there is a prep course channel. And that is the place to ask those questions. And as soon as you ask a question, you will find out how helpful people are, because we've all been there before. And we're just really keen to help people. And often students will come in and help each other, but the TAs are around as well, and they'll be keeping an eye on all the different Slack channels. But for prep course people, there's this one specifically for you. So if you've got any issues setting things up, that's the place to ask. Okay, so let's now, I'm going to close that down and go to my notes. So on the right-hand side, you can see like the student notes. So that's just sort of guide you to what we're talking about. I should zoom in on that a bit, I think. There we go. And then on the left-hand side, I've got my Visual Studio code zoomed in, so hopefully you can see that. So I'll be live coding on the left and the notes will be on the right-hand side. So let's just have a quick overview of what Python is. So Guido van Rossum began developing Python in the late 1980s. This is quite an old language. He aimed to create a language that was easy to read with a clean and intuitive syntax. I certainly feel that they've achieved that. And the name Python was inspired by the great British comedy group, the Monty Python's Flying Circus. Now, if you're unfamiliar with them, I highly recommend Googling the Dead Parrot sketch. It's a good entry-level Monty Python sketch to get you into Monty Python. They're great. Okay, so the first public release was in 1991, and then the first production level version where people could program with it was in 94, and then version 3 was released in 2008, and we should all now be using Python 3. In this workshop, we're going to work with Python's built-in REPL. That stands for read, eval, print, and loop. It's just a programming environment that allows you to explore Python without creating files and executing files. You just write the code in a REPL, press enter, and it executes it. So I've opened, I've got VS Code up there. I'm going to, first of all, just check that I am in Python 3. So I'm going to type Python and then Python-version, just check. Yes, as long as it comes back as 3 point something, that's all we need. So I know that I'm working the right Python. If that doesn't work, it's because you haven't got your path variable set up. That's something that's I'm not going to go through today. That's in our books. All you need to do is type instead Python 3 version. If you do that, then you will get up which version you're in. Okay, so let's get the REPL up and running. So to do this, you type Python or Python 3 if your path variable is not set up. So I type Python, and here I am. I'm now in the REPL. I've got these 3 greater than symbols. And on a Mac in VS Code, you do Command K and it clears the screen, which is very handy to know. So this is where we can just write code. So I can just do 1 + 2. That's Python code. Gives me 3 when I press enter. I can print something. So I could just print hello, and it will print hello. And then to get back to the terminal, if I want to stop writing Python code and I want to go back to editing files and things, I do Control D, and that gets me back. On a Windows machine, I understand that it's Control Z. So Control Z for Windows, but Control D for a Mac. So let's have a look at some Python data types. So there are lots of data types in Python, which makes it a really versatile language. However, to get started with Python, you don't need to know about all of them. So we're just going to cover the most useful ones today. The data types can broadly be grouped into 2 categories: primitives and non-primitives. The difference between them is that primitives can't be broken down into smaller objects, whereas non-primitives collect several things together into a container object. And I'll try to reflect that in my visual in the student notes. So we can think of primitives as being tools. So there's a hammer. You can't, I mean, you can break a hammer down, but it stops being a hammer and it's not useful. And same with a screwdriver and a tape measure and whatever. So those are primitives. Whereas non-primitives are your toolboxes, where you put your hammer and your screwdriver and your chisel and all those things inside. And interestingly, sometimes toolboxes contain toolboxes. And again, non-primitives can contain primitives, but they can also contain non-primitives too. We're not going to look at any of those today, but I just wanted to show you that my analogy works quite well, because you can put a toolbox within a toolbox, just as you can put non-primitives inside non-primitives. Now, what I could do is list off all of the data types and tell you which is a primitive and which is non-primitive, but I think that would be a bit boring. So what I'm going to do is have a quiz, just to see if you can deduce which data types belong to which category. Now, if you're completely new to Python, this might be more guesswork than educated guesses. If you have some familiarity, then maybe you know this. And I've also put some red herrings in there. So there are a couple of items that are not Python data types, because different languages use different names for data. So that's just to keep on your toes. So remember, this is just for fun. I can't see individual answers. And once we've done the quiz, we'll just take a few minutes to do the quiz. I will go through and explain what the answers are, and then you'll know. So let's get going. So Python data types, I'm going to launch it. I'm going to give you a couple of minutes to do it. Just give it your best shot. Like I say, it doesn't matter. I can't see what anyone's answering. It's always a bit of relief for me when I can see that people are filling in. So I've not started the wrong quiz, and you weren't all expecting Ruby or JavaScript or something. Everyone's in the right place. I'm just going to give another 30 seconds or so. And anybody eagle-eyed will be able to see my cat sitting on the bed behind me saying, "It's time for bed. What are you doing?" Okay, so let's have a look at the answers. So I'm going to end the poll, and then I can share the results so you can see. And then I'm going to put the answers up here. Oh, I was meant to put that in there. So the first question, integers, right? Integers are primitive. So integers are whole numbers, 1, 2, 3, 56, minus 1008. All of those are integers, and those are primitives. They can't be broken down into smaller parts, even though we all know about fractions and they can. As far as Python is concerned, they are primitives. Right, so the next one is a dictionary. Dictionaries are non-primitives, and we're going to cover that when we go to the non-primitive section, but it's basically pairs of data. And so yeah, it's just pairs of data. So number 3 is number. Now in Python, number isn't a data type, and it is in other languages. So don't worry if you got this wrong, because if you were learning a different language, number would be a data type. But in Python, we don't have numbers. We have integers and we have floats. And floats are just decimals. So number, not a Python data type. Then we've got an array. Again, Lots of languages have arrays, but not Python. Python calls them lists. So an array and a Python list is just a list of things. And so this is a non-primitive because it is a list of other things. It can be a list of integers or a list of floats. And then, oh yes, so I've answered number 5, list. That is a non-primitive. And then question 6, string. A string is just another word for text. That's pretty standard across languages. Most languages talk about strings. That's a primitive in Python. Excuse me, that's a primitive in Python. Again, it isn't in all languages, though. Some languages consider strings to be made up of objects of the characters. So I'm just going to stop sharing that. Don't worry if you got any or many of these incorrect. That's just not going to determine your ability to code. The more you work with Python, the more you'll become familiar with which data type is available to you and which type they are. When you learn a new language, it'll have a different set of data types, and some of them will be primitives that weren't in Python, and maybe the other way around. And you'll need to pick that up in your new language. But the more languages you pick up, the easier each language is to learn, because actually they're all, variants on a theme. So they do all have something that looks like a list in Python. It's just other languages call it an array. So like I say, don't worry if you didn't get those right. It was just, for me, a more fun way of demonstrating which data types are primitives and which are non-primitives, rather than just giving you a list. So in the next 2 sections, we're going to explore the primitives and non-primitive data types in turn, so we can learn more about them. So let's move to primitives. So these are our tools, our hammers and screwdrivers and things. So they're a single thing, they're atomic, they're not made up of other things. So we've just learned from the quiz, this includes integers and strings. It also includes floats and booleans as well. So we're going to start with strings, basically text. These are usually defined in single quotes and they can contain any character. So I'm going to move into my REPL on the left-hand side here. So I can just create hi. Oh no, I need to be in my REPL, so I need to type Python. And I'm going to do Command K to clear the screen. So to create a string, I just put it in single quotes. So I'm just doing hi. But it can be any characters. This is also a string, as is this. Just because it's 1, we know that it's a number. We've put it in quotes. As far as Python's concerned, that's a string. Now, if you want to use quotes in your string, then you can use double quotes. So if I want to do she's coding, I can use an apostrophe in that if I put it in double quotes. But similarly, I can use single quotes to put double quotes inside. So he said hi, and put the double quotes inside the single quotes. And then in Python, triple quotes are also a thing, and they're used to create multi-line strings. So I could do 3 quotes, and then I can just put there, say, dog. I can put counter return, who said bye, and wagged his tail. And then I use 3 quotes to end it. And then I get back that string that I've just created. In that you can see some backslashes. So there was a dog, \n, and the backslash is an escape character. It tells Python that the next character is special. And in this case, the n means it's a new line. And using \n for a new line is pretty standard across languages. There are other of these escape characters that you'll find out about as you move through the course. But this is probably the first one that most people come across, is the new line one, because with the triple quotes, you're wanting to create something over several lines. And so here you go. When you create the string, you can see you've got these escape characters in there. Now, as well as creating single strings, you can also combine strings with the plus operator. So I'm going to clear the screen, and we can do foo, and then we can add bar, and I get foo bar. If I want to do hello world, you can see from the foobar one, it doesn't insert a space. It literally concatenates the strings together. So if I want, I've got to correct the punctuation here. If I want a space between the strings that I'm creating, I need to insert that. So that's why I've got hello plus a space, excuse me, plus world. I press enter and I get hello world. So using the plus operator on strings is concatenation. Right, so moving on from strings. Python has two data types related to numbers, as I said before, integers and floats. So 1, 2, 3, an integer minus 6. That's also an integer. And then if we want a float, we just put a decimal point in between, and we can do negative floats as well. These can be combined with all the usual mathematical operators, which I showed you before. 1 add 2, we can do 3, take away 1. To multiply, you use a star. To divide, you use a forward slash. So 4 divided by 3 is 1.33 recurring. I'm going to clear the screen, scroll around to the bottom again. Then to do to the power of, 2 to the power of 3. So 2 times 2 times 2. So 2 times, 3 times. I use 2 stars. I think it's because I didn't put them together. There we go. So 2 times 2 times 2 is 8. So 2 to the power of 3 is 8. There's also an integer division. So if I do 7 divided by 2, Python will take an integer, and if you do division, and we know that it's a float, it's 3.5, Python will give back 3.5. Other languages will stick to integers and just give you 3. But Python's good. Python won't give you an incorrect answer just because you started with an integer. And it will say, no, 7 divided by 2 is 3.5. But you can also do integer division, which is when you use 2 forward slashes. And this one returns the largest integer less than or equal to the floating point result. It rounds down. So 7, using the integer division, 3 gives you, oh no, I should have done that 2, so that was similar. 2 gives you 3. And if I do something that evenly divides, so 6 into 3, then I get 2. So it doesn't round down if it's exact. And then there's the modulo operator, which is basically the remainder. So if I do 7 divided by 2, I get 3.5. I'm just going to clear the screen. So 7 divided by 2, I get 3.5. If I do the integer division, I get 3. And if I use the modulo operator, I get what's left over. So 2 goes into 7 3 times, we get to 6. And then we've got 1 left over. And that is what the modulo operator gives you. And it is really, this is something that you'll use more than you realize you needed. It's quite often to find a remainder of something. And particularly if you want to know whether a number goes into another number, obviously we know 2 doesn't go into 7, but once the numbers get quite big or we're iterating through something, it can be really useful to compare the modulo to 0, because if it equals 0, then we know the number is a factor of the other number. The one thing I'm not going to go into here is that both integer division and modulo operator may not behave as you expect when you start using negative numbers. So it's not something to worry about. It's just something to be aware of. And just check it out in the REPL if it gives you problems in your program. And often it can be better to have different cases for negative numbers and handle that yourself, rather than getting Python to use these operators with negative numbers, because it can get a bit confusing. But whatever floats your boat, if you can cope with the negative numbers, then it's fine. So the last primitive value we're going to examine is Boolean. Now, Boolean value is either true or false, but without quotes. So we have true. Oh, no. Let's start that again. So we have true and we have false. So those are the two Booleans. So they're capitalized and they don't have any quotes around them. And these are the results you get when you compare different values. For example, using the equality operator, which is just two equal signs. So if I say to Python, is 4 the same as 4? Python will say, yes, true. If I say, is it the same as 3? Python go, no, that is not the same. And I can also use the equality operator to compare strings as well. And Python will say, they're not the same. And this, I'll just note, is case sensitive. So have no and no, where one is capitalized, Python will say they're not the same. So when you're comparing strings, they've got to be the same case as well. There's also a not equals to operator, which is pretty useful. And that gives you the opposite of the equals to operator. So if I say, is 4 not equal to 4? Python says, no, they are equal. So if I do is 4 not equal to 3, Python says, yes, those are different. Again, you can use that with strings. And then Booleans are also returned from ordered comparison. So we can do the usual 4 is less than or equal to 4. Yes, it is. But is 4 less than 4? No, it isn't. And then we can also do this with strings. If I do AB and I say, is that less than CD? Python will say, yes, it is. So when strings are compared, Python does it lexicographically. So they're just compared character by character from left to right, and it depends on their order in the ASCII table. With the ASCII table, we don't need to worry about that today. It's basically alphabetic. So because A comes before C, Python considers AB to be before CD. If both the letters are the same, then it will then compare the second letter and so on. So play around with this to see what happens when strings are of different lengths. And then what happens when you throw capital letters in there as well. How does Python compare those? So now we're going to have our second quiz to combine primitives and operators. And again, some of these questions are not things we've explicitly covered. It's just designed to explore things a little bit further and a bit more interesting. So give it your best shot and then I'll explain the concepts afterwards. So here's the quiz. So primitives. So give this a go. Okay, I'm just going to give you another 15 seconds or so. If I'm not giving you enough time, please put something in the chat and I'll make sure I'll give you more time for the next quiz. But I don't want you all sitting there twiddling your thumbs, getting a bit bored either. Okay, so let's now have a look. Just going to share the results and then put the answers up here. Maybe I should have cleared this. Okay, so first question, 1 add 2.5. I haven't even got the right answer there for you. I really am. Oh no, that's just that I haven't changed this. This should be 1 plus 1.5. There we go. 1 plus 1.5 is 2.5. So Python will let you add integers and decimals and floats together. You don't need to worry about converting the integer into a float to add them together. Python can handle that. And the second one, ABC less than ABCDEF. This returns true. So if both strings are the same up to the shortest length, then the shortest string is considered to be the least. So for these two, Python will compare, you don't need Grammarly, A and A, they're the same, so it moves to the next one. B and B, that's the same, moves to the next one. C and C, they're the same, and then it moves to the next one. But in the first string, there isn't a next one. So it says, right, well, you're smaller than another string that has got the same characters as that, but more characters on the end. So that's how Python works when it's comparing strings of different lengths, but that are the same up to the shortest one. When you add two strings, they're just concatenated. So this will give you AB, so you can add strings in Python. But if we try to do an integer plus a string, we get an error. Python doesn't let you use the plus operator with a string and a integer. Again, that's something that's different in other languages. JavaScript just lets you do anything. So again, don't worry if you get these wrong, because they're different in different languages. And so you just have to learn the particular quirk that it is. The decision that was made when Python was created was that you cannot add integers and strings together. However, you can add Booleans together. So if you do true, add false, add true, the answer is 2. And there were some people that got this right. Well done. But again, don't worry if you didn't, because this was a decision that was made. When we add Booleans together, Python converts those Boolean values into integers. True is 1 and false is 0. So here we've got 1 plus 0 plus 1, which is 2. It's implicitly doing this because we're not telling it to do it. So it's just something to be aware of. Like I say, in other languages, you might get an error. Or, I mean, it might just return false because it might be considered to be and. So again, don't worry if you haven't got it right, because it will be different things in different languages, but you're learning Python, so you need to know that when you're adding Booleans, Python will convert them to 1s and 0s. Just play around in the REPL. If your code is going wrong and you're adding Booleans together, this is probably what's going on. Okay, so let's now have a look at non-primitives. Sorry. There are quite a few non-primitive data types in Python. We're just going to look at a few of them today. We're going to look at lists, tuples, tuples, dictionaries, and sets. So let's have a look at lists and tuples first. So is there any programming use case in adding Boolean values together? Oh, I don't know. You might do. I suppose if you're comparing the answers to different things and you want to know how many of those answers were true and how many of them weren't, you might want to add them up. But I've never done it, so maybe it's not that useful. But good question. So lists and tuples. So the student notes might look like a particularly tricky game of spot the difference here. The difference between lists and tuples is that lists are enclosed in square brackets, whereas tuples are enclosed in round parentheses. But other than that minor visual difference, they do actually have a different they do have different qualities. That is why there are these two different things. So in other languages, lists are often called arrays. They're probably the best known sequence type. So sequence is just a list of things in an order. So to create a list, you just enclose whatever it is that you want in your list in square brackets. And we can do mixed data types. So I can do, I don't want to do that. I can do a string, a Boolean, and an integer all in the same list, and Python doesn't have a problem with that. If you want to access a specific element in a list, you use its index. So I'm going to create a list of strings, and first, second, and third. If I want to access the first element in this, I use the index 0. Brings me back. If I want the second one, I use the index 1. And if I want the third one, I use index 2. Now, starting at 0 when counting elements can seem unintuitive. It's certainly caught me out a few times. It still catches me out now and then. One way to think about this is that when you look inside them, you would start at the first one automatically. When you just go inside the list, you're already there. So to find the first one, you don't need to move anywhere. So it's just 0. But to find the second one, you need to take one step. So it's index 1. And to find the third one, you need to take 2 steps. Because I started at first, 1, 2. I need to take 2 steps to get to the third one. So that, that is my explanation as to why the indexing starts at 0 again. This is very standard across programming languages. We are starting at 0. But just be aware of it, because when you're looking at a list of things and getting offered something, you might have 1, 2, 3, 4. But when you create it in a list in Python, it will be starting at 0 and not 1. So now let's have a look at tuples. So tuples, very similar, but created using a round bracket. So I can just do 1, 2, 3. Again, I can use, I can't type and talk, mixed data types. That's fine too. The difference between them is that lists can be mutated and tuples cannot be mutated. So to demonstrate what that means, I'm going to need to show you how to create a variable, which means I'm sort of giving the game away for what I'm going to show you later. But anyway, I'm going to need to show you how to create a variable and then some element reassignment just to demonstrate this. So I'm going to create a variable list. So LST equals is how you create a variable. And I'm just going to put 1, 2, and 3 in there. So if I type LST, I get the 1, 2, 3 back. I can do element reassignment. So if I do the list name, list, and then use the square brackets with a 1 inside, and then equals 99, here I'm reassigning the second element in that list to 99, and this is mutating it. So I do that. Now when I type list, it's 99. So this demonstrates that lists can be mutated. If I do the same thing with a tuple, I need an equal sign. So if I do a tup equals 1, 2, 3, so I type tup, I've got 1, 2, 3. If I try to reassign the middle value to 99, Python says no, the tuple object doesn't support item assignment, and that's because tuples can't be mutated. So this is really useful because If you're creating a list of things that you want to be able to add things to, change them, take things away, you use a list. If you want to create a list of things, but once you create it, you don't want it to be changed. Like you're creating the alphabet. I mean, the alphabet's pretty standard. You want to list the alphabet. You don't want people adding things and taking things from it. Then you use a tuple, because once you've created it, nobody can mess around with it. So to summarize, both lists and tuples are ordered data. So once you create them, the order stays the same. So when you get something from index 0 or 1 or 2, it will be predictable, will be the same all the time because they're ordered. They can be mixed type data types. And the only difference is that lists can be mutated, they can be changed, tuples can't. Now let's move on to dictionaries. Again, another collection of data. This time, they're denoted by curly braces. They're similar to lists and tuples in that they contain a set of data, but the data is stored in pairs. Similar to a dictionary where you have words and definitions. So that's what you can think of. The keys are the words and the values are the definitions. So when you provide the key, Python will give you the value. So I'm going to create one here. So I just use my curly bracket. I'm using a string here, my key, and I'm going to use an integer for my value. So first 1. And if I want to do several, I separate them with commas. So here, my keys are going to be animals, and then my values are going to be the noises they make, which are also strings. So if I do cat and then meow, like that. So I've just put a comma between them, just like we did with list and tuples. We put commas between each element, and we put a comma between each pair of elements, like that. Just like with list and tuples, you can reference a single value from a dictionary. So if I go up, because I'm a little bit lazy, if I do dict equals this dictionary, so now I can get it back, I've got it in memory. If I use the square brackets again, just like I did with the indices, and do a key value, it will give me a key. It will then give me the value that is associated with that key. And just like lists, they are mutable. So if I do dict dog and say equals woof, now if I look at dict, we can see that the value associated with dog has changed from bark and is now woof. So dictionaries can be mutated. So what are valid data types for keys and values in a dictionary? So anything can be used for a value, just like lists and tuples, including lists, tuples, and dictionaries sets. They can all be used as values in a dictionary, but keys are limited. So the technical term is that the data type used for a key has to be hashable. That's a concept that's discussed in the PY110 course, a little bit far off from where some of you are now. So for now, we can just use this as a synonym for immutable. So keys can be anything that you can't change. So they can be strings, integers, floats, booleans, and tuples, and other things too. So anything that you can't change, you can use as a key. But you can't use lists because lists are mutable. The keys must also be unique to the dictionary. So no two keys in a dictionary can be the same, which makes sense because otherwise, when you gave the key, how will Python know which value to give back if you've got it in there twice? So our last non-primitive we're going to look at is sets. So again, here we are using the curly braces, again, just like the dictionaries, but this isn't pairs of data. This is more like lists and tuples where you've just got a list of data. But sets are an unordered collection of objects. So, I mean, it looks like there's an order, and if I created it, it would come back the same. So again, if I do that. And I can also create one with different data types in. I can't put true in there. Isn't that interesting? Can't put true in a set. I'm still learning. Interestingly, though, they've got to be unique. So if I try to create a set with duplicated items in it, Python will just remove the duplicates. Because sets are used to determine whether something is in it or not. So you don't pull back particular elements in it. If you want that, then you need to be using a list or a tuple. A set is just used for something where you're just determining whether something is in it or not. Just like sets and dictionaries, just like lists and dictionaries, sets can be mutated. So you can add things to sets and you can remove things from sets as well. Okay, so let's have a quiz to review what we've learned about non-primitives. So give this a go. I should probably take that off the screen. Okay, so I'll give you another 30 seconds or so. Okay, so let's have a look at those answers. Share the results. The answers. So the first one is a pair of data. It's curly braces, so that's a dictionary. The second one is round braces, so that's a tuple. The third one, curly braces, the single elements, so that's a set. Then the fourth one is square braces, so that's a list. Then, so that, I mean, this is just, as you use them, you won't get confused about this. But when you're new and you haven't been using, dictionaries and lists and tuples and sets, they do look very similar. But once you start using them, you will learn this. You do not need to sit down and rote learn this. Believe me, once you start programming in it, you will learn. And then which of these are mutable? So list, dictionary, set. Those are the ones that are mutable. Tuple is the only one of these four that cannot be changed. And then which of them have no, why did I ask a negative question? And which of these have no constraint of uniqueness? That's a list and a tuple. So a dictionary, the keys have got to be unique. For a set, the elements have got to be unique. So it's only list and tuple that have no constraint of uniqueness. And I think I might change that question for next time, because asking a negative is not a good idea. Right, and so thank you to the anonymous attendee who said it looks like creating a set with true didn't work because it took true as being 1. And so you can see on the left-hand side where I'll try this out. So if I do 1, 2, and false, Python says, yeah, false, 1, 2, absolutely fine. 2, 3, true, yeah, not a problem, that's absolutely fine. It's only when I try to put true, well, I'm not actually typing anything. It's only when I try to put true and 1 in a set together. I think you can't have both, so it just keeps the first one. And same with false. So false is the same as 0. And so it just keeps the first one. So thank you, anonymous attendee. I have learned something new tonight, because I am still learning Python 2. Okay, great. Now we are going to have a very, very quick look at variables. And this is our last topic. So you've already seen me use variables to demonstrate things being mutable or not. So variables store information that we can use later in the program. So that's why they're really useful. And we can think of them as labels for data rather than containers. I know some people like to think of variables as containers. When you get through the course, you'll understand why that breaks down a little bit. Labels is much, much better. So let's create a couple of variables. So I'm going to do first name is Bugs. I'm going to do last name is Bunny. So I've just used an equal sign to assign these strings to each of these variables, first name and last name. And then I can use the plus operator to concatenate them. And again, it will concatenate them. So I'm just going to put a space between them. Oh yeah, I did mean first name. Oh, I was really wondering what I'd done wrong there. Okay, so first name plus last name gives me Bugs Bunny. Now, make sure that you give variables meaningful names. It's more important for them to have a meaningful name than a short name, so that our programs are understood by other people and understood by ourselves, even just a day later. If you use cryptic things, then it can make programming much harder, because you have to translate in your head what that thing was, rather than just naming it what it is, and then you don't need to do that translation. There are conventions for naming variables in Python, which you can see from what I did. So to separate two words, you use an underscore. So I didn't use camel case, which is when you use a capital letter to separate words. I used an underscore. So first name. So the conventions for naming variables in Python are snake case. This is called snake case. Looks like a snake. It's got to be lowercase letters, digits and underscores. And it's got to begin with a letter, not a number. So you can have numbers in there, but it must begin with a letter. And in a later workshop, we're going to explore variables in much more detail, especially regarding mutation and thinking of variables as pointers. but for now we can just think of them as labels for our data. So this was the last topic for today. So let's have a quick look at what we've learned. We have covered, I just want to put a few characters down. We have covered data types. We then looked at primitives, so integers, strings, booleans, floats. And then we looked at non-primitives, so lists, tuples, dictionaries, sets. There are others. And then we just had a brief look at variables. So now I'd like to open the floor to see if you've got any questions related to what we've covered today. And while I'm waiting for that to come in, I'm going to give you a roundup quiz. So this is just a summary of everything that we've covered today. So I'm just going to start that. Why won't it let me launch it? The poll has been launched in this meeting. Polls. There are no polls. I didn't close the last one. Okay, stop sharing. Thank you very much, Quinn. Oh, thank you. Right, so roundup quiz. Oh, I'm going to be really disappointed that you didn't get my last quiz. Thank you, Quinn. So off you go with that. I'm going to clear this screen. And yeah, if you've got any questions, put them in the Q&A. If you need to hop off, don't forget to fill in the feedback form, please. I really, really would like you to fill in the feedback form. I will read every piece of feedback you give me. And if you tell me what's working, I'll put more of that in. And if you tell me what's not working, I'll put less of that in for the next people. So you'll really be helping the next people that take this workshop. So please fill it in. Make sure you hang around after you press submit. Don't immediately close your browser. As I learned when I was filling in feedback forms, I have to fill one in as a leader. And people saying to me, Claire, why are you never filling in your feedback form? I do it every time. But it was because I was closing the window too quickly. I was just a bit keen. Oh, and I've got this nervous minute of when nobody has completed the roundup quiz. Oh, no, but 2 people have now, so now that's okay. Don't forget, if you've got any questions, put them in the Q&A, but maybe don't, because I've just been really thorough. Please, I'll give you another 30 seconds or so, put something in the chat if you need longer. Still, I'm quite impressed with myself. We're 1 minute before the hour and I've not run this one before. So I'm quite impressed with my timekeeping skills. Okay, let's have a look at the answers. And that sharing. Okay, so let's have a look at the answers. So which of these are data types in Python? So integer, float, string, list, and Boolean. Other languages do have number and text and array, but Python doesn't. So for numbers, we use integers and floats. For text, we use string. Rather than an array, it uses lists. When we compare 3 and 3.0, Python says, yeah, they're the same, even though one of them is an integer and one of them is a float. Python says they've got the same value. They're the same. Phew, that's good. What's returned when we do hello and world? I mean, I've already shown you this. I don't know, this is a particularly good question. I should change that one. It will put them together. It concatenates them without space. There is a way, there's a method to use if you want things to be separated by spaces, but if you just use the plus operator, it just puts them together. So it's the second answer where it's just hello world without space. To reference the Tweety element in this list, it's the second element. So we use the index 1. Everybody nailed that. Well done, you. For question 5, to reference the value for the author key, we don't use an index because this is a dictionary and we can't rely on the order of dictionaries. Some languages would use like a colon and the key name, not in Python. Some languages, JavaScript, I'm looking at you, you can just do dot the key name. That's really handy. That's one of the things I really like about JavaScript. Can't do that in Python. Is you need to do book, and then in square brackets you need to do the value of the key. So in this case it's a string and it's author, so it's the last one. Again, don't worry if you didn't get this right, because in different languages it will be different things, and you just need to get used to how Python does it. And then which of these follow Python convention for variable names? The only ones that do are the first and the last one. So the convention, just because you can do something doesn't mean that you should do it. So snake case, using underscores to separate words. So that's why first name is fine. And then the last one, you can use numbers, but they mustn't be the first character in the variable name. So first name camel case, that's not convention for Python. Using a hyphen instead of an underscore, that's not Python convention. And putting the number first, also not Python convention. Okay, stop sharing. I can't see any questions that have come in, so I'm just going to assume that I was just really thorough and I've just answered everything. So now let's have a look at what we'll be doing next time. So I need to pull up the slideshow. So next time we're going to look at functions and variable scope. So following this, I hope you've learned something about data types and variables. I've learned that you can't put true and one in a set. So just play around with these things. Don't be afraid of them. If you're already in the prep course, keep working through that. If you're not, then why not? Because it's free. So you might as well take advantage of the resources that Launch School's got. There are also some other workshops that are running at the same time as this one through the week. So check those out. Those are on the website. What I do want to say is that the main way of communicating with other people at Launch School is our Slack community. And it is very vibrant when you're in the right places. So general is where you're going to get general information like this Python workshop is going on. If you've got things that are specific to the prep course, how do I set up my machine? Some questions about Python basics, because you're in the prep course, put that in the prep course one. If you've got a pet, there's the gratuitous pet photos, and that is possibly the most active one. I'm very active in there myself. I really enjoy that one. There's a chess one. Just have a look around. There's a women's group as well. We meet every 3 weeks or so, but there's a Slack group for that. So Slack is the way in. So if you're not already on Slack, get on Slack and start exploring around and joining some different groups, because that is how you get to know the community here at Launch School. And people are really helpful. I've never reached out to someone at Launch School and they've ignored me, let alone been unpleasant. Everyone here is lovely and really constructive as well. People are really keen to help. So do reach out, and you can even reach out to me because you can get hold of me on Slack as well. Okay, so next time we're going to do functions and variable scope. That will be fun because then we start, doing bits of code that we can, things can happen and we can change them and store it. So the last thing for me to say is to please fill in the feedback form. It's really useful, so please fill it in. Even though I know it's a little bit tedious, but it's not that long a form and a lot of it is multiple choice. And thank you for your lovely words. Oh, that's really sweet. I hope to see you all then, same time next week. Blake, yes, coming from the Ruby course, you found this interesting. They do have a lot in common, which in some ways has made Python quicker for me to learn. But then in other ways, I think it's easy for me to get confused between the two because there are quite a lot of similarities and they're not really different, whereas JavaScript is very different from Ruby. Yeah, so enjoy the rest of your day. Oh, look, someone's already filled it in. There is a star in the group. Thank you. I now have to pronounce your name. Javier? So I'm just going to paste it in again, just in case anyone missed it. Yeah, so enjoy the rest of your evening, and I will see you all next week. Goodbye.